and something else. My network is secure. They're using Airtel Geos of the world and whatnot, right? You imagine if anything gets stuck somewhere and that user is going to come and catch you on it because they're going to say, hey, I signed up for your platform, your app, and now your app is not secure, that's why my data is leaking. So all of this is very important in this context. These are some terms I just wanted to show you. I can walk you through all of these today's conversation. One of the most important ones, which is a non-profitable organization called OWASP, which is over here. This is basically a web platform-driven thought process and then policies that they take to ensure that nothing is broken. And this is pre-mobile era, right? How many of you are web developers here? I know I'm a decade-old dinosaur, but how many of you actually, when you were still studying in your school and colleges, you saw some mentors or you saw someone saying, "Have built this web app"? Now this is pre-mobile era. How many of you think that security was a problem back then? You know the biggest scam in the world, not the scam 1992 wala, no, not Mehta Saab. But the point is, there are loads of people who were still breaking the internet by stealing data, which were not theirs, and web was still a problem. Similarly, next came mobile app security. These are guidelines that the middle tier people, the other organizations said, okay, we have OWASP, but we have nothing mobile specific. Mobile is something that is in your pockets right now. Some of you are clicking, some of you are probably scrolling. The point is that web is very different, mobile is very different. So that's where this mass came up. And then MSTG was another suite of penetration testing. Penetration testing is when you take a piece of binary, APK or something, and then you go and run it against a test suite. How many of you write unit tests? Okay, for people who didn't raise hands, next session is going to be about unit testing. Because it is very important. It's very important to write tests so that you can cover your own code base, right? Okay, so after saying all this, how do we check and verify? So it's going to be divided into two sections. I'm going to show you what the attacks are. So I worked at a company called Gojek. Gojek was one of the biggest Indonesian companies. It's now rebranded as GoTo. We had a huge problem. We were primarily an Indonesia-based company. Okay? We were based out of India. All engineers used to have perks in INR, but working for a different country. But the amount of illegal apps, we used to launch a feature. It's a paid feature. You have to do this 5 steps. You have to earn the trust. How many of you use Uber to come here today, or Ola, or whatever? Sorry, I don't even know how many different apps exist today. But just imagine if your driver says, "Yeah, sir, I'm right here. I'll pick you up in 1 second. Can you please give me the OTP?" And you very trustfully give it. This person is still sitting in his couch in his underwear and he's like playing FIFA on his console. Imagine a Ola driver or Uber driver or any app just treating you because he's making a money on this platform because he has a hacked APK. We had that same problem at Gojek. We had this huge potential where there's an app that was already leaked in a certain way. They were able to crack some of the algorithms and they were able to modify it. Okay. I'll show you some examples of what we did. Yeah. But before I show you what could go wrong, I just wanted to bring your attention to this thing called mobile app security and requirements and verification kind of a testing guide. Okay? The ideology is that when you design your architecture, you think about security also. It's not just fancy designers giving you a fancy UI, writing in Compose, Flutter, this, that, and all. Irrespective of what technology you use, it's also important that you think about all of these. Where you're going to store your data, how is the data privacy going to be rectified? If something goes wrong in platform, how many of you have seen Android security updates? Know what Android security updates are? Everyone knows what operating system updates are. But have you ever noticed silently in the background for all the Android phones, even iPhone, there are these silent updates that come to your phone without your knowledge. You don't have to give permission or select install. It automatically does that. These are security patches by security experts who tell to the agencies or to these mega companies like Google and Apple or even Microsoft that potential risk factor that Android can be compromised. Now this is a little advanced thing. I just want to ask one question. I'm pretty sure 0 people over here would know about it, but still I'll try my luck. How many of you know of a small little device, nothing bigger than this, called a flipper? Oh, okay, I'm very surprised people know about it. Flipper is like a magic tool. You press few things, there are few commands. It can hack into anything. It can, if I have an RFID, I have a hotel key card, it can mimic that. If I have a phone, it can mimic that. If I have a credit card, it can copy it. Just because it's in proximity. How many of you have bought an RFID blocking wallets? You know the security potential of that, right? Imagine you just I keep my wallet here, okay, chalo, lunch pe chalte hain, and then I go for lunch, and then 5 people come and scan my credit card and they start using it. So all these things, how to store data, also applies to physical things. But when we talk about Android, most important thing is how your network calls occur. I'm not talking about games, I'm not talking about simple apps that are just hello worlds of the world. These are complex problems. Imagine if Jio Cinema, you pay 999 rupees for subscription and you don't get the premium content. There's no problem at Jio Cinema side. Someone is intercepting your Wi-Fi connection and is consuming your data, but you don't get it. Imagine you pay 300 rupees for 1 Gbps speed, correct? And the limited data, I know we are living in a world where everything is unlimited, but you get a bill for 5,000 rupees instead of 300. What happened? Someone has already infiltrated your network. So all those like potential bugs is what this test guide thing is. Okay? So before we begin, there are 2 different categories, very straightforward. Now remember, this topic is very advanced, but I'll try to dumb it down as possible. The reason is because I myself took 3 years to understand this, how people do this. I was so fascinated when I was a kid that what do these people do? How do they, how many of you seen movies where there are consoles? They're green color consoles and some random Python code running, and then they're hacking the NASA, the space stations and whatnot. I was very fascinated by that. But I also thought in my mind, what are those, how do I even distinguish what is correct, what is wrong, morally? But if I'm a moral engineer that I want to solve for the problem, I'm going to look at 2 things. I'll generate an APK, I'm going to get ready to go to Play Store, sleep for 3-4 weeks, and then maybe Play Store will review my code and then publish it. In the meanwhile, I'm going to run something called a penetration testing. The first thing I'm going to do is static analysis. What I'm doing here is static. How many of you know what static means?
Not changing.
Right? The value never changes. So the thing is, I'll draw a line here. All of you are APKs. Without actually running you on an Android simulator, emulator, whatever, or phone or in a tooling system, I'm going to go and investigate what is there for you guys. A simple math is that I want to understand what all you have hard-coded. How many of you have written your API keys into shared preferences? You log in, you authenticate, you say shared preferences dot put string, and then you put your auto. Well, welcome to reality. I can easily hack your app. I can become kind of a copy of what you are doing, and I can literally maliciously go and copy everything that you have done. I can copy your credit card information just from a token. I know that backend has its own security protocols, but I can also, from your Android app, just because you wrote something into the shared preferences, I can go and read it, right? And this is not even running it's not running the APK into an environment. All I have to do is go and look at what the APK is. Yeah, sorry, go ahead. Yes. Yeah, sure, please.
So shared preferences in the documentation itself, it's written just for dark mode, light mode, or even if you're writing something important, can't you just encrypt it and write it?
That's the thing. So that's a very valid point. See, when you store something, you're already thinking in the right direction. That's the goal of the store. When you're putting some data into a file, or you're storing a user's, user doesn't care what auth token is. And we are in a world, we are in a country where next 100 million users are coming online today. Right? As we speak, there are many of our citizens in this country still don't have a mobile phone. They're coming online. They're still realizing what internet is. They're still going to download your app. Oh, Jio. Oh, okay, there's Ola, there is this and that. Imagine if you're an engineer in one of those apps and you store something in a file. I can go and start reading it. That's the point I'm trying to make. Okay? The point here is that if you notice at the very bottom, sorry for people at the back, JDX, ID, Pro, Grida. Don't worry, all the slides will be available, don't worry, don't focus on those. These are all illegal tools, but they're also meant for the open source community that you protect yourself from all of this. What I'm going to do is I'm going to start reading all your preferences, even if it is encrypted. SHA-256, SHA-128, all these are algorithms, very easily crackable if you use the right tools and you give enough time. Not millions of years, just enough tools, you crack it, you'll start working. The goal is, in static analysis, I'm taking your APK and breaking it apart. Okay? So if you look at it, what happens? This is the one side of the equation. Dynamic analysis is where, how many of you have rooted phones? Do you know what root is? Okay. Can you please call 100? Police, there are people here hacking illegally. The point is, rooting is not illegal. The point is that if you use rooted devices, things that you protect, the question that you asked, if I stored something in shared preferences, you say, okay, an end user who's using a regular phone will not be able to access those files, they're secured. Even if you have a secured storage, even if you put it in a web server, just because I'm in a rooted device, it's like you log your home, you're all here, I duplicate myself, I go to your home and I steal everything from your home. And that is what dynamic analysis is. I go to your environment, I break your systems, I go and break your digital cameras and whatnot, and then I access things. Same with APKs. Okay? How many of you have heard of man-in-the-middle attacks? Right? Now, imagine that there's this website. How many of you used to play PUBG in India? India banned it. You know why? Because there were certain countries, certain affiliations of certain countries that were capturing some data from a. They were basically doing a man-in-the-middle attack. They were running some data from your capture. Even if you click shoot, how you click it, what network you're on, where you are right now, how many transactions you have done, all of that information was captured. The EPK is not supposed to do that. It's just a stupid game. It's supposed to give you the entertainment. But there were services written in between that would capture that data and send it to some malicious people. So these are all man in the middle. So I've said enough. Now let's go into practical knowledge. Before I do that, how many of you know what Android architecture is? I know it's not a library. How many of you know what Android architecture is? Application layer, system layer, data layer, and then finally the hardware layer. That thing that I asked you before, Flipper, it's a Bluetooth hardware hack. It's also software. It basically connects to your Wi-Fi network. It can hack your Wi-Fi password. Even if you use a very complicated Wi-Fi password, just because you're using an Android phone, it can enter your network. The attack surface is growing. When I say attack surface, it's a military term. I can attack you from not just nuclear, not from coming in to your country and bombing you, but also simply just send a virus to your computers. Something very similar. APKs can be deciphered. But how does it get deciphered? If you look at source codes, left side is native development, right side is also native development. Irrespective of what language you use, you will compile your code into a class.jar and then you will push it into Dex. All of you agree, right? All of you are aware of how this thing works. The right side is simple native code. It could be libraries. All of you might have used something called analytics. Okay? How many of you played Angry Birds? Do you know that it was built in C++? The entire framework was built in C++. The graphics was just layered on top. Even the graphics, the bird jumping and throwing and all that, everything, the dynamics, pulling the string back, everything was C++. That is what is happening there. Okay? If I take this APK, this is what we upload to the Play Store, right? Forget about AAB and all those fancy things. Everything is just a simple zip. I can go to an unzipper, or the famous 7-zip. Anyone knows what 7-zips are? Okay. Or WinRAR. Okay, good. My generation. Good. When I open your APK, I can start seeing this. See, what I'm doing is I'm just using a tool called unzip. This is a Mac operating system, simple unzip tool. I give it a property that please unzip this zip file. APK is just zip. Guess what I get in return in that folder? Once the operation is complete, it starts giving me the manifest file. It then gives me the meta, classes.dex, libs, and everything else, including assets. So imagine if you put some fancy icons. You bought it for $4, $5, whatever. Very, very fancy things that you want to protect. Just by unzipping, I'm not even showing you how complex security hacking is. This is as simple as just unzipping the APK, I can access it. What happens here is that I can now run static analysis on these files. Remember, I'm not running this on an Android, I'm still on a laptop, Windows, Unix, whatever you want. I can even do it on my Android phone. There are tools on the Android, there are APKs that allow you to break other APKs. The point here is that you might see some blue links at the bottom left of me, or bottom right of yours. The idea is that it takes the debuggable information. How many of you have written network internet permission required? How many of you have not written it and then crash occurs? I can break that. Even though Android system wants internet permission to work, only then it will allow you to allow your app to connect to internet. I can change that. Just because I have an APK, you as developer forgot to add it. I can take, as a user, I can take your APK, go to the manifest file, edit it, repackage it, reship it, and then install. I can do all of this and change it. What I'm trying to show you here is that there's a lot of things. How many of you have bought an Android phone in the last 4 years? Okay. What was the phone before that? Another Android? How seamless was it to transfer from one phone to the other? Google backup, right? In that case also, everything can be broken. Now, in software engineering, it's a simple math. We start over here on the top left. We design something, we write the problem statement that I want to do with my APK square and integer. I'll give you 2, what is square of 2? Oh, thank God, okay, good. All are awake, great, okay. Now I have to write logic for this. I'll put it in some Java, Kotlin, Flutter, whatever your poison is. Then that gets converted into machine code, the third paragraph. And that again further goes down into system level code. Nothing fancy. All of you do this every day. This is how we make income. I make income by reversing it. I take the opposite steps. I have this, I have the APK at the bottom. I see some random alphanumerics. I go one step back. I open symlinks. I then go back to something called as the text files converted back to its class.jar. A very crude version of it. Just by downloading a free tool, I can look at how bad our engineering code is. Anyone's. You give me one APK, I can tell you how many activities you have, what kind of architectures you have written. I can just take one APK and reverse engineer. Okay? The whole goal of this talk is to prevent this from happening. Okay? Now, if I take your APK and unzip it, this is what I'm going to get. I know it's very blurry, I'm really sorry about it, but is this familiar code? It looks like an activity code. Yes. Guess which app this is? How many of you use Telegram? Yeah? No, this is the Android Studio, but the code. Sorry, I have an APK that is opened up. I've gone reverse. This is Telegram app. I can look at what activities they use, whether they use Jetpack Compose, or whether they do something else. I can start looking at the code back in replay, right? And imagine if I go and now modify this code and create the APK back and then send it upstream again. I can say, hey guys, this is new amazing app called Telegram mod. How many of you have done that? You find a game and you want a mod. You don't want to pay 5 rupees or 10 rupees for your game. Or you want a WhatsApp premium feature. Or you want Facebook without the ads. You can modify it like this. It's as simple as that. But this is still illegal. What I'm trying to show you here or educate you is that you need to prevent your apps from getting into my hands. Or anyone's hands in that case, right? Okay. There are some tools. Again, please re-emphasizing, please use these only for educational purpose. Don't use it on someone else's app. Try and break your own code and try to see what's correct. Okay? Okay, static is fun. Dynamic is even more fun. Because now I get hands on a fancy new Pixel 8 or something. Because I can then break it. So I've been indicated I have very less time, so I'm going to skip through a lot. Okay, so this is man-in-the-middle attack. I'll run your APK in an environment where I can intercept all network calls. Imagine you're at an airport. Never ever use airport Wi-Fi without a VPN. Have you heard this from your seniors or someone in your peers? Has anyone said this to you? The reason being, I can create a Wi-Fi network that intercepts everything that goes. Right? Okay. I can take that connection. This is Charles, by the way. You can use HTTP Toolkit and many other tools. You can start reading the HTTP token to that question before. Even if I showed it in auth preferences, I can still read it. Okay, moving further, slightly running now. Storage preferences, the question that you asked. By running this kind of packaging tooling, I can start reading all your files. It will literally throw out everything in raw string. Anything that you put in your shared preferences. Remember, now I'm running this tools on an Android, the APK on an Android phone. Okay? Behavior analysis. We take a lot of this information and then I can change one thing. How many of you have written an error code? If OTP is wrong, don't allow the login. What if I tell you I can change the entire behavior itself? I'll skip the OTP page itself. I'll write some random auth token and I'll say to the server this is correct auth token. Right? Let's say you are an authentic user. I'll take your authentication and put it in someone else's phone. That is what dynamic analysis is. Literally phone-driven thing. Okay? And one of the most famous things. How many of you have played Pokemon game? How many of you have used a fake GPS of spoofing your location? Did you know you can have modded Pokemon games that allow you to just sit in your couch and roam the world and still capture all the Pokemon? They debug all this code and then run behavior analysis. What the code does. What I'm trying to highlight here is they access an API called location from Play Services. I can literally mock it and say, yes, please always send this location. And simulate a walk, simulate a run, all those things, okay? Secure communication, very straightforward. Do not say go to a default app. How many of you have written a code which says open always Chrome browser? The very bad strategy. Because you don't know what the compromise is. The Chrome browser could be some malicious package. It could be adit.lal.chrome, not com.google.chrome.dev or whatever, right? I always remember that a user should have power, and that is what this is for. Should always show an app chooser because let the user decide. If there is a security compromise, they will fix it, right? Next, use intents for IPC. All of you know what IPC is. Today's topic is not about IPC, but the intention is that you take a simple thing and then you break it down. Okay? Next, the same thing, when you pass a permission, one thing I want to highlight, if you can follow my finger, signature matters. If you send everything in raw format, explicit intent, just pass it to this guy, without actually controlling the factor, it will break for you, okay? Most important, network security. How many of you have used this code in the last 6 months? Had a crash because you didn't write clear text traffic. The reason Google made this mandatory is because there were people who were maliciously controlling this as well. So when you say false, no one can access it, at least at this level, okay? Now, very simple, sorry, I'm going to speed run this. Do you see a problem over here? Exported true. Very bad idea. The reason being, because I can now access this. To change this, I can use a tool called Dozer, and I will start hacking your app. And I can bypass your login page and all that and directly go to your home page. Because I can just say this activity should not be run. Next is false. Just make it false, okay? Don't worry, all the slides will be available. I'll still be here. I'm here today and tomorrow. There are many other attacks. How many of you have played Pokemon again and then you saw an app that comes on top? Like a bubble. Like a messenger app, that bubble. They're actually they're basically intercepting all the touches you're doing on your phone. They can even simulate that. There's a very easy solution. Fix your permissions and write a simple. Just write this: filter touch obscured. If you draw another thing on top of your app, do not allow the touch on my app. There are loads of those people who go and touch banking, PIN, they try hundreds of things and they can capture. It's like if you go to an ATM, you put your PIN code and someone else is watching it. That is what is happening. Or instead they put you on a gunpoint and say, I will type it for you. That is what happens even on APIs. Permissions, very straightforward example. Go and read about it, nothing fancy. Please use permissions, don't find a way around it. There is a reason why security permissions exist. Okay? I'm just skipping this because it's very straightforward. I just want to highlight one last thing over here. When you say allow backup true, make sure that it's encrypted. If you just think, Google will handle everything, it's not the case. There are loads of other things that I can go and break for you. I start using your data. Because when you say allow backup true, you're saying everything can be backed up. Even the files that you store. You downloaded a Hotstar movie or some kind of fancy thing. I can start decrypting it and start publishing it on random channels for paid content. It's not my property, but I can steal your IP. Okay? When you think you can work with different algorithms, don't think that. Anyone can break it. Always remember there are multiple layers of security you have to put together. Again, shared preferences, use encrypted shared preferences, nothing complex. The idea here is that you're allowing the end customers to be as secure as possible. Okay? Now, I have 2 slides. Sorry, I'm just going to take 2 more minutes. One very important point. Please go and talk to your managers. Don't put the user is clicking this, user is a male, user is doing this, now user is doing this, one step further, one step further. Too much is too much. Just by reading your analytics, if I hack your analytics here, I can capture everything your app does. The lesser, the better. That's the whole point over here. Okay? How many of you use Logpad? I'm pretty sure everyone does, or some kind of timber or something. Program it, please. Do not just write APK just thinking, log will be okay, no one can read it. The minute I run dynamic analysis, I can start reading questions. Yeah, sorry.
I have a question.
Yeah.
If we use RA in full mode, do you think that is still reversible?
Yeah, I can reverse it. There's a whole, so do you know that ProGuard is actually like a baby version, free version of something called DexGuard. Yeah. It's a company run by GuardSquare. There's a more advanced topic on that, we can discuss it later, but I can completely reverse engineer RIT. Anything that APK even goes through an RIT. Sorry?
Even on full mode?
Yes, even on full mode. It is just basically, it's like tiers. Okay. So you're saying I'm going to be protected by security guard. Next I'm going to put a dash cam in front of my, like a camera, a security camera. Then there's a dog inside the house, and there's something else. So all those, right? All these points I'm making is all captured in this. Don't worry, slides will be available. If you want to scan, you can. Anything that I missed today will be covered in this simple course. If there's any dependency that you have and you're curious, I put this is nothing. This is just 0.005% of what all tools are available. It took me 3 years to work at a team that were reverse engineering our own APKs so that we can protect ourselves from. I was in a team called Trust and Safety. We were trying to protect drivers and customers to not reverse everything that we've done and write protection layers on that. Okay? With that, thank you. I think I'm running 2 or 4 minutes late. For any questions, I'll still be around. I don't know if we have any time. No, 0. Okay, we have 3 minutes. Okay, great. I want to take questions. Anyone has any questions? I know I raced through a lot of the content, but the whole point is to make you aware that there are so many tools out there that can break things. One of the best things that you could do is OWASP, find those guides, and then try to reverse. Yeah, sorry.
Do you think certificate pinning is safe?
No. It's the first thing I'm going to crack. That Charles thing that you saw,
Right.
that Charles screenshot where I'm going and authenticating, you may have certificate pinning 2 layers, 3 layers, I can still go and break. Do you know that Google has an API called SafetyNet API? It checks whether your app is running on a compromised system like rooted devices or so forth. It also checks whether certificate pinning was disabled by any chance or if there is some kind of man-in-the-middle attack and so forth. I can still very easily bypass it. And with that, very good question. It's also a point that when you work on network, it's not just one-way street that, okay, always Android app is the problem. It's also the backend problem. This problem is not from one side, it's both sides. Okay, yeah.
If you can, so you're basically saying that no matter what the app is, with static analysis, you can reverse engineer it to see
the code, just the code, yes.
Okay, any app.
Yeah.
And then further you're saying that in dynamic analysis, you can edit the code, you can intercept all network requests.
Correct. So it's like I come to your home and I break your Wi-Fi while sitting next to you.
So which app would be safe and like, how do you safeguard against this?
So there are tools. Sorry. Okay. There are tools that allow you to disable all this or detect that this is happening in the meanwhile. So you disable all the features that are not meant to be.
What kind of RSA algorithm might protect or not able to be decrypted?
It's not one answer. There are multiple things that come together.
Okay.
And multiple things.
So RSA algorithms can be break.
I won't say that we as engineers can break. It's a lot of effort. It takes years and years and months and weeks to break one simple password. But there are tools out there that already exist that can break it to a certain level. Okay? Yeah.
We can obfuscate, right, to avoid dynamic.
So with DexCard, people can de-obfuscate it within 10 minutes. It takes 10 minutes to, we had a 150 MB file, the APK when unzipped. I was able to de-obfuscate everything within 10 minutes. I was able to read secure things within the APK that were not supposed to be leaked. So we then went and wrote better way of writing those code. We went and spent more time with DexCard to figure out what ProGuard rules will allow me to obfuscate. So if you remember, in ProGuard you can also say 3 layers, 5 layers, do 10 things, 5 things. It's a mutation of different problem sets. 2 and 2 together will not actually solve everything. It's an everlasting battle. Instead of becoming a reactive approach, be a proactive one. That's the whole goal of this talk. Yeah. Any other questions? Oh yeah, sorry, please.
If the ProGuard is not safe, then why are we using it in the first place?
Well, there are loads of companies that are buying software and writing other tools on top of ProGuard. ProGuard is still the default choice. If you realize not every app will be broken. But if you're a big company like Marks and Spencer's, Barclays, or heck, even like Flipkart and all that, how many of you would like to buy free products tomorrow? You start hacking today, you start ordering things and you don't have to pay about it. Right? You don't go through the payment gateway. You just say success, order placed. So every company has some tool or the other. The goal is that you need to realize what the potential threats are. It's like spreading your arms and okay, come and sting me. Right? As soon as you go out, there are 10 people who are going to be malicious and they're going to try and attack.
You are telling that we can write something on top of ProGuard to protect.
Yes. So see, it's about architecture of things. If you think just putting it in shared preferences, putting it as a simple certificate pinning and then getting those, just setting it out, oh, I'm done. Oh. That is just 0.001% of the security prevention method that we have applied. There are 10 other things that you can follow. That is what OWASP is for. There are toolkits, there are CLI toolkits that take an APK and tell you how many vulnerabilities are there. If I take the Telegram app, I found 156 vulnerabilities on the static analysis. imagine I'm more malicious, I go to an Android phone and start breaking things. So that's the thing. Yeah? Okay. I think I'm going to be kind to the next speaker. I'm going to step out of this deck, and if you have any questions, I'll be here. The slides will be available. You can follow me on Twitter, and I'll also make sure the organizers post this. Thank you.